Hello, in today's lesson we are looking at the volume of prisms and cylinders. Our goals are to use the volume postulates and to find the volumes of prisms and cylinders. What is the volume of a solid? The volume of a solid is the number of cubic units contained in the solid's interior. Imagine a box of cereal. When we talk about volume, we're talking about the cereal inside the box and how much cereal the box can hold. So that is what this definition means. Postulate 27, volume of a cube. The volume of a cube is the cube of the lengths of its sides, or V equals S cubed. Postulate 28, volume congruence postulate. If two polyhedra are congruent, then they have the same volume. Postulate 29, volume addition postulate. The volume of a solid is the sum of the volumes of all of its non-overlapping parts. Theorem 12.6, Cavallari's principle. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Theorem 12.7, volume of a prism. The volume V of a prism is V equals BH, where B is the area of the base and H is the height. Theorem 12.8, volume of a cylinder. The volume V of a cylinder is V equals B times H, which is equal to pi r square H, where B is the area of a base, H is the height, and r is the radius of a base. Example 1, finding volumes. Find the volume of a right prism and the right cylinder. For this example, there's two ways to do this. The first way, according to the notes, is to find your base. Your base is the two congruent shapes that are parallel to each other. So in this case, my base is this shape here and this shape here. Notice that this is a triangle. So what I first need to find is the area of the triangle, which is 1/2 base times height. So I would do 1/2 of 1 times 3, which gives me 3/2 feet square, and then I would take that and multiply it by the height, which is the length that connects the two bases. In this case it's 2, so I would do 3/2 times 2. 3 times 2 is 6. 6 divided by 2 is 3, and so the volume of this right prism is 3 feet cubed. Another way to do this is to go back and remember two-dimensional shapes. If I have a rectangle, I can find the area of the rectangle by multiplying the base times the height, or length times width. If I cut the rectangle diagonally, it makes a triangle, and all I have to do to find the area of the triangle is take the base times the height and multiply it by 1/2. The idea is the same for a right prism. In order to find the volume, what I could do is multiply the length times the width times the height, which is 3 times 1 times 2. And then since I cut it diagonally, I would just divide this by 2 or multiply it by 1/2, same thing, and I would get 3 times 2, which is 6. 6 divided by 2 gives me 3 feet cubed. For part B, I have to find the volume of the right cylinder. First, I need to find what my bases are. My bases are circles. The reason why it is a circle is because I have two congruent circles and they are parallel to each other. So first I'm going to find the area of the circle, which the area is pi r square, where my radius here is 5, so I will do pi times 5 square, or I know that 5 square is 25, so it's 25 pi. And then I would take this and multiply it by the height. Remember, the height is the length that is connecting the two bases, so I would take 25 pi and multiply it by 6. 25 times 6 is 150 times pi, and plug that into the calculator. You get that your volume for your right cylinder is approximately 471.23 meters cubed. Example 2, finding volumes. Use the measurements given to solve for x. In example 2, we are given the volume of the three-dimensional figure, we need to find what the side lengths are. In the first problem, we are given that the volume of the cube is 90 feet cubed. We need to find what the side length of this cube is. I know the formula for volume of a cube is volume equals s cubed. So where volume goes, I'm going to replace that with 90. And then to undo a cube, I need to take the cube root of 90 and plug that into the calculator. I get that the cube root of 90 is approximately 4.48. And so the height, width, and length of the cube are about 4.48 feet. In part B, we are given the volume of the right cylinder, which is volume equals 1,253 meters cubed. We need to find the radius of the cylinder. We also have the height over here. So we start by writing the formula volume equals base times height. We know that the base for a right cylinder is the area of the circle, which is pi r squared. Here we're just going to rewrite r as x, so it's just going to be pi x squared. We know that the volume of the cylinder is 1,253. We know the height of the cylinder is 10. We're just going to rewrite this formula by moving 10 over here before the pi. So we have 1,253 is equal to 10 times pi times x squared, where x represents the radius. Isolate x squared by dividing both sides by 10 pi. So we have 1,253 divided by 10 pi. Plug this into your calculator, and what you get by dividing 1,253 by 10 pi is 39.88. which is approximately equal to x squared. Solve for x by taking the square root of both sides, and the square root of 39.88 is 6.32. So the radius of the cylinder is about 6.32 meters. Alright, checkpoint problems number 1 and 2 are yours. For each of these problems, find the volume of the solid. Round your result to 2 decimal places. For problem number 1, find the volume of the right prism. For problem number 2, find the volume of the right cylinder.